This is a demonstration of the KenKen Fast Optimization Solver, a project for the Software Engineering Capstone program. This application was developed by Team 15, Austin Whaley, Danny Molnar, and myself, Sean Spencer. This demo will provide a brief overview of what KenKen is and show how our application solves KenKen puzzles. KenKen is a type of mathematical puzzle developed by Tetsuya Miyamoto, a Japanese math teacher, in 2003. It was created to help students develop mathematical and logical skills. These puzzles are a grid of squares ranging in size from 3x3 to 9x9 in size. Inside this grid are cages, which have an interconnected set of squares with a target number and operator. You must place numbers in these squares that produce this target value, and each value has that operation done to it. For example, let's look at a simple 3x3 KenKen puzzle in our application. In our application, we have a puzzle selection menu that has an example of each puzzle size. Let's choose that 3x3 that I mentioned. Here, we have a 3x3 KenKen puzzle with 5 cages. You can determine a cage based on the thick outline and the target value in the uppermost left-hand corner of the cage. We'll see other cage shapes later. The middle cage here shows a 5 with an addition operator. I would have to pick two numbers that add up to 5 in this case. The numbers I'm allowed to use are based on the puzzle size. Since this is a 3x3 KenKen puzzle, I can use numbers 1 through 3. This would be relatively easy, but KenKen has a few additional rules. Each column and row needs to contain all numbers based on the puzzle size, in this case 1 through 3, and numbers cannot be repeated in each row. This constraint leads to a specific solution to a given puzzle. In this case, if I wanted to solve it, the top left-hand cage has a 3 with no operator. The only value that can go into this cage is a 3. This middle cage has to have two numbers that add up to 5. I could put 3 and 2 here, which would add up to 5, or I could put 2 and 3 here. In this case, because I know 3 needs to be in the top left-hand corner and numbers can't be repeated, 2 and 3 would make the most sense here. As puzzles grow in size, the difficulty of solving them in this way increases dramatically. This isn't just hard for people either. Computers have a difficult time with this, and that's why solving puzzles of greater size is considered an MP-hard problem. Our program hopes and seeks to help those looking for solutions to KenKen puzzles and are also interested in the efficiency of how a computer can solve a KenKen puzzle with a given algorithm. Let's see this in action. So I'm going to solve that 3x3 I have up on the screen. By default, our most powerful algorithm is selected, the graph solver. If I choose Solve Puzzle, it will attempt to solve the puzzle and display the amount of time it took. Again, the graph solver is our most powerful algorithm and makes short work of 3x3s. Let's see that in action. So that took only 5 milliseconds. Now, let's see what that looks like with a harder puzzle. Let's jump all the way to the highest difficulty, a 9x9. So here's a very difficult puzzle. Let's see how long it takes to solve with an alternate algorithm, like the brute force algorithm, one of our weaker ones. I can select an algorithm from the top left-hand drop-down here, and I'm going to choose brute force. I'll come down to the bottom row here and hit Solve Puzzle. And if we wait for just a few seconds here, we'll see if we get a solution. Now at the bottom, before it showed our solution time, just a few milliseconds. Here it said solution wasn't found. These alternate algorithms here are placed for those interested in algorithm efficiency, and we default to our graph solver for those looking for solutions in the least amount of time possible. Here, the brute force algorithm didn't work out. Our application has a built-in timeout when an algorithm takes too long to solve a puzzle. Brute force would work well on smaller puzzles, though, up to about 4x4. Let's solve this now with the graph solver. Great, and there's our solution. Took just over 7 seconds. So let's see this in action again, and we'll choose a different algorithm. I'm going to reset my board here, and I'll choose a 5x5, load that in, And let's check out our iterative solver. Solve the puzzle. And there we go. Just under 2 seconds to solve a 5x5 with our iterative solver algorithm, which is good up until about 7x7s. Now, we could also have our users load a puzzle from disk into our application. They don't have to use the built-in puzzles that our application ships with. We can go to Choose File, and here I have some puzzles that are on disk. I'm going to choose this 8x8 that I have. I'm going to hit Load Puzzle to load it into our app, and I'll choose the graph solver again. And there's the solution. 62 milliseconds, pretty fast. So that's all for application. We hope you enjoy using the KenKen Fast Optimization Solver, and thank you again from Team 15 and Swang 481.